problem up here. I want to use a half angle formula for tangent. So this asks us to find tangent of a over 2 if we know that sine of a is 2/3 and a is between pi over 2 and pi. I do need to have some information here about where a is, because if I'm going to use one of these formulas, I need to know both sine and cosine. And if I'm going to use this formula, I would need to know cosine, which I wasn't given, and then I'd also need to be able to figure out whether to choose the plus or minus for that square root. Okay. So I think I'm going to avoid this formula because it involves the square root and the plus or minus. I'm going to pick one of these. So let's first of all just figure out what cosine of a is. So we're told that a is between pi over 2 and pi. So I know that a is in quadrant 2. I'm going to let alpha be my reference angle. I'm going to drop a perpendicular to the x-axis. And I know that sine of alpha is just the absolute value of 2/3, which is 2/3. So 2 for the opposite side, 3 for the hypotenuse, and let's find our adjacent. So a squared plus 2 squared is 3 squared. A squared plus 4 is 9. A squared is 5. A is the positive square root of 5. Now I'm taking the positive square root because remember, I'm just labeling the sides as actual side lengths for the triangle with alpha in it. I'm not doing sine sides, although if you prefer to, you can. But now with that, I can say that cosine of a is going to be a two-step process. I'm in quadrant 2, so cosine is negative, and then adjacent over hypotenuse is going to give me a root 5 over 3. Okay. So now I know sine and cosine, so I could actually use either of these formulas. I'm going to just notice that sine doesn't have any square roots in it, but cosine does. So I'm going to use this formula, because that way I'm putting the square roots on the top of my fraction, whereas if I use this formula, I'd be putting the square roots on the bottom of my fraction. So that's just a little bit of strategizing to try to make the simplifying of my final answer a little bit nicer. Okay. So let's see, let me clear some space here. Okay. So I'm going to say that tangent of a over 2, I just copy the formula, 1 minus cosine a over sine a. That's going to be 1 minus a negative root 5 over 3, all divided by 2/3. So I do have some simplifying to do. I'm going to rewrite that 1 as 3/3 minus a negative is plus root 5/3, all over 2/3. So now I can write that top as just a single fraction, 3 plus root 5 all over 3. And I'm dividing by 2/3, so that's really just multiplying by the reciprocal. Now I can cancel those 3's, and I'm left with 3 plus root 5 all over 2. Not too bad. Kind of like that one. Okay, so let's try another one. Let's find tangent of a over 2. This time I'm going to tell us that cosine of a is 1/4, and 3 pi over 2 is less than a is less than 2 pi. Okay, so I actually have two reasonable choices here. I know cosine of a, so I could use this formula because that's the only trig function I have to worry about. I would then just have to take the square root of the whole thing, so I'm going to have a fraction under a radical sign. And I would have to solve this for a over 2, because I'd need to know what quadrant a over 2 was in order to determine the plus or minus sign. My other option is that I could use one of these formulas. Then I would have to figure out what sine of a is, but once I've done that, it's just a question of plug into the formula and simplify. I actually think that's simpler, so that's going to be my preference. Although if you want to do it the other way, totally fine, and you should get the same answer. Okay. I'm going to suggest that you pause the video and work this out. Okay. I'll actually work it out both ways, using one of these and using this one. So you can pick which method you want to do. I'll work out both of them when you come back. I do think one of these is easier. And again, I'm going to choose which one to use by the fact that cosine doesn't have any square roots in it. So I'm going to like this one because I'm expecting that sine's going to have some square roots in it. And I prefer to put my square roots on the top if I can. Now, sometimes sine and cosine both can involve square roots. If that's the case, it doesn't really make a difference. But when one of them doesn't have any square roots, that's the one I like to put on the bottom. Okay, so pause the video, come back, we'll do this version first, and then we'll do this version. Welcome back. Okay, so I know that A is in quadrant 4 because it's between 3 pi over 2 and 2 pi. So here's alpha, my reference angle, and there's my right triangle with alpha in it. I know that cosine of alpha is just the absolute value of 1/4, and that's 1/4. So I can draw the adjacent side as 1 and the hypotenuse as 4. Then I want to find the opposite side. So 1 squared plus p squared is 4 squared. 1 plus p squared is 16. P squared is 15, and p is the positive square root of 15. Not necessary to write that positive, but I like to just remember that I'm making a choice. This would have two solutions if I were just solving an algebra problem, but I'm solving a geometry problem. I'm finding that side length. Okay, so then I can say sine of A, two-step process. I'm in quadrant 4, so sine is negative, and then it's going to be root 15 over 4. Excellent. Okay, so if I plug into this formula, tangent of A over 2 is going to be sine A over 1 plus cosine A. So that's negative root 15 fourths over 1 plus 1/4. Now, I'm going to rewrite that as negative square root of 15 fourths over, I can write that 1 as 4 fourths plus 1/4. So negative root 15 over 4, all divided by 5 over 4. And of course, I can just flip and multiply. So negative root 15 over 4 times 4 over 5. Cancel those 4's, and I've got negative root 15 over 5. And that's as simple as I can make it, because there's nothing I can factor out of that root, and I can't cancel something under a root with something not under a root. Okay, so I'm just going to record up here that what we got was negative root 15 over 5. Some of you might have preferred to use this formula, so let's just take a look and see how that would work out. That's going to save us having to figure out what sine of A is, but we then have the task of using this inequality to figure out what quadrant A over 2 is in, so that we can determine whether we want the plus or the minus sign. Okay. So I'm going to divide this by 2. So remember, that means that I'm multiplying by 1/2 if I already have a fraction. So we get 3 pi over 4 is less than A over 2 is less than pi. 3 pi over 4 would be here, pi is here. So A over 2 is in quadrant 2. Okay, so I know that tangent of A over 2, I'm just going to copy the formula, is either plus or minus the square root of 1 minus cosine A over 1 plus cosine A. Now, I'm going to say we're in quadrant 2. A over 2, the thing I'm taking tangent of, is in quadrant 2. And in quadrant 2, tangent is negative. Okay, so that's where I'm using this information. And then it'll be the square root of cosine A was just 1/4. So 1 minus 1/4 over 1 plus 1/4. Now, I'm going to rewrite that I can rewrite both of those ones as 4/4. So I've got 4/4 minus a fourth over 4/4 plus a fourth. So that's going to be negative the square root of 3/4 over 5/4. That's going to be negative the square root of 3/4 times 4/5. Dividing by a fraction, I just flip and multiply, and those 4's are going to cancel. So I'm getting negative the square root of 3/5. Okay. Now, I'm running out of space, so I'm going to erase what I've got up here and just simplify that. So negative the square root of 3/5, that's negative root 3 over root 5. Don't want a fraction under the root, so split it up. Don't want a root in the denominator, so we'll rationalize by multiplying by 1 in the form of root 5 over root 5. And that's going to give me negative root 15 all over 5, which is exactly what we got the other way. So either one does work, and you can decide which one you prefer. Okay. In general, if I don't know cosine of A, I'm not going to find this one simplest. If I'm given sine of A and I've got to find cosine of A to use any of these formulas, I'd prefer to use the ones that don't have the square root or the plus or minus. I might, when I'm given cosine A, find this to be the simplest one. I would probably still go with one of these two, but it really is just a matter of personal preference because they're all right and you're allowed to use any of them.